Hello, my name is Alexander Dunn and I'm what's known in Ansell as a technical expert. I work within the Ansell Chemical Guardian department and it's my job primarily to use the data generated from this lab and others within Ansell to be able to find the best products suitable for our customers. So this is our gas chromatograph flame ionising detector, or GCFID for short. This works off a similar principle to the electrical conductivity you would have already seen, in that we have two sides of a cell separated by a piece of fabric, and in one side of that cell we put a chemical, which is also known as the challenge chemical, that then permeates our fabric and is collected on the other side of the fabric. The collection medium takes that sample away to the detector, and through that detector we can quantify and find out how much chemical has passed through the fabric. The main difference between the GCFID and other detection techniques like electrical conductivity is, although they work on the same general principle of testing, they differ in the types of chemical they can detect. So electrical conductivity can detect non-volatile chemicals, whereas the flame ionising detector can detect volatiles. What we mean by this is it can detect any chemical that can readily evaporate. So after a chemical has permeated the fabric, it'll evaporate into the nitrogen stream and this will be taken away to the detector for quantification. There are a number of permeation standards that can be adhered to when performing a standard permeation test. Although they largely run off the same principle, and you can show data for all of these in one permeation test, there are some differences in how the data is calculated and what information is shown in the final report. We're going to go into detail now about some of the ways this information is shown, and the two major ways are in standard breakthrough times and in cumulative permeation. Cumulative permeation differs in reporting to normal permeation data. It can be readily described by an analogy of imagining two cars driving down a road. If this road has a speed limit of 60 miles an hour, the first car drives down this road at 55 miles an hour. After reaching that speed, it travels for the whole journey of 480 minutes and is never stopped by police as it never goes above the speed limit. This car will travel approximately 440 miles. Now imagine a second car along the same road quickly accelerating to 80 miles an hour. Once it goes above this 60 mile an hour limit, it's stopped by police and its journey ends. In this case, it only manages to travel approximately 60 miles. If we relate this analogy back to permeation, if we imagine the two cars as the two permeation tests, and we imagine the speed limit down the road as the permeation breakthrough limit of 1 microgram per centimetre squared per minute, we can see from this data that the first car, although didn't reach the speed limit, permeated far more overall than the second car, which broke the speed limit and was stopped. This is an important and key point to remember, because we can see that permeation is occurring even though breakthrough time may not have been shown. This is why safe use time isn't necessarily the same thing as a breakthrough time. Cumulative permeation is useful in this case because the car or the glove under test, which wasn't stopped throughout the test, did show permeation. Cumulative permeation will show this permeation overall. This is why it's important when looking at breakthrough times and other permeation data that this is supplementary information for a risk assessment and shouldn't be replacing a risk assessment altogether. So to summarise, our GCFID and electrical conductivity are staples of our laboratory to be able to test standard chemicals, both volatile organics and single acids and bases. However, as you'll see from later videos, we at Ansell like to go above and beyond what's standard permeation testing.